and welcome to today's session. My name is Swapnil Hendre. I'm a Director of Solutions Engineering and Design. I have been with VMware for about 10 years now, and my team is responsible for leading solutions architecture from inception to go live. And SD-WAN is one of the most critical projects the team has been leading over the last year and a half. During today's session, we would like to share VMware IT journey to SD-WAN. Today, I'm joined by Nick Ford from my team. Nick, would you like to introduce yourself?
Yeah, sure. Thanks, Swapnil. Good morning, everyone. My name is Nick Ford. I'm a member of the IT Solutions Engineering Design team here, and I'm based out of the Palo Alto and San Francisco area. I've been with VMware for about 4 years, and we've been working on our journey, which we're happy to share since about late 2018. And I've been involved everything from the initial proof of concept to the first deployment to our offices and data centers.
Okay, thank you, Nick. So let's quickly go over the agenda. So this is kind of a high-level agenda we are going to go with. The first, we'll talk about what's SD-WAN and why did VMware IT decide to go ahead and roll out SD-WAN. Then we'll talk about the two unique use cases we have for VMware IT, followed by day two operations, where we'll talk about how to operate SD-WAN post-deployment into production. And finally, we'll conclude with question and answer. Feel free to post your questions in the chat, and we'll do our best to answer all of your questions at the end of the session. Okay, so let's get started. So we'll talk about the use cases. So during today's session, we are going to talk about the two use cases for SD-WAN rollout. The first one is the SD-WAN rollout for our data center to branch office connectivity. And the second use case, it's something we started about 4 or 5 months back. And this use case is related to most of our colleagues working from home. All of us are in this pandemic, and our goal was to provide improved colleague experience for our colleagues working from home. So we'll talk about both of these use cases. One is an enterprise use case and one is a consumer use case. Okay, so let's begin and let's talk about why we chose SD-WAN. So before we start, let's quickly go over the VMware IT's infrastructure footprint. So this will give you an idea about why we decided to look at SD-WAN specifically. VMware IT has about 60 offices globally, and these are categorized into two tiers, the tier 1 and tier 2. Tier 1s are generally considered the mission critical. Hence, at every tier 1 office, we have 2 internet circuits and 2 MPLS circuits. And the tier 2 sites, we have 2 internet circuits and 1 MPLS circuit. Now, all our offices are connected to each other using MPLS. And when we developed our WAN architecture long time back, and it was state of the art at the time, over the period of time, we started facing few challenges. So 3 key challenges to be specific. The first one was cost, second one was availability, and third one is agility. So let's start with the cost. So based on our internal research and review, we realized that the cost of the MPLS is traditionally 3 times higher than the cost of the internet circuits. And since the cost of the MPLS was so high, we had to compromise on the availability for our tier 2 sites. And hence in the tier 2 sites, we have 2 internet circuits and 1 MPLS circuit. That means if we lose an MPLS circuit in our tier 2 site, that site becomes completely isolated and loses the connectivity to rest of the VMware infrastructure. Hence, this was one of the single point of failure, and which was our availability challenge. And the lastly is the agility. So we could not really manage our WAN infrastructure from single pane of the glass. We had to manage and maintain the infrastructure pretty much separately. And as you can imagine, all these steps, all this entire process was quite manual for us. So we had to manage and maintain every site separately. So obviously, there is room for the human error and the lack of the consistency, which leads into the operational issues for us. We were also noticing that over the period of last few years, there has been a major push to migrate the enterprise applications to cloud. So quite a few applications have been migrated to the cloud, and our colleagues who access these applications, we couldn't provide them the optimal connectivity. So these three challenges we were facing. When we looked at the SD-WAN, we realized that all these challenges can be addressed by SD-WAN out of the box. The first one is we can use internet as a transport for branch to branch communication. Hence, we can not only reduce the MPLS cost, but we can also provide, we can also eliminate the single point of failure issues which we had. And our goal is to get rid of all the MPLS connection over the period of time. When Nick discusses how exactly the data flow looks like, he will talk about how we decided to expedite our MPLS decommissioning. The second one is DMPO, or Dynamic Multipath Optimization. That helped us eliminate our blackouts because we can use the per packet steering to steer the packets to second link. The MPO also helped us resolve the brownout issue. So brownout is sometimes we see the issue and the issue is quite inconsistent. And that was our WAN engineer's nightmare because by the time they log in and start checking, they can't really find the issue. And the brownout issue was also addressed by DMPO. So the way it works is when we have the two links and if one of the link is degraded, the SD-WAN automatically detects that and automatically performs the traffic steering. And lastly, the SD-WAN leverages internet to provide the secure and high performance connections from branch to the cloud. And that helped improve our colleague experience significantly. Let me give you an example what I mean by that. So for example, the Office 365, Zoom, Teams, and there are a lot of applications which are hosted in the cloud. But when we were using the SD-WAN, before using SD-WAN, we were not getting the optimal performance. With SD-WAN, the benefit we get is we have the VeloCloud gateways, which are strategically placed across the globe, which are positioned close to these services. So for example, if you want to access, let's say Office 365 or Zoom or Teams applications, the SD-WAN VeloCloud gateways will provide the optimal path for our colleagues. And we have seen significant benefit with that one. And finally, we were able to simplify the QoS by using the app ID feature with the SD-WAN. With the app ID feature, we can prioritize the application traffic based on the application IDs. Now that we talked about what is SD-WAN and how it's been helping us, I would like to turn it over to Nick to do a deep dive. Nick, you want to take it from here?
Yeah, sure. Thanks, Swapnil. Awesome. So what we're kind of looking at here is we have an overview of a common VeloCloud architecture, right? So Swapnil just went through a few of the SD-WAN benefits, and we're going to kind of use this topology to go a little bit deeper on some of those topics. So if we look at the left-hand panel here, we see that there's three major building blocks to the VeloCloud architecture. We have the orchestrator, number two at the cloud gateway, and then we have number three, the edge. Right, so if we look at the top of this diagram, we have at the number one position, right, the VeloCloud orchestrator. So this orchestrator is going to be a multi-tenant SaaS-based solution, and it's going to provide the centralized management platform for all the configuration of all the edges. So any kind of IPs that you need to assign to the interfaces, any kind of routing changes, BGP changes, right? You can do this all from the cloud platform, and it pushes those changes down to the VeloCloud edge in itself. And then with the orchestrator, everything is API driven. And one of the highlighted features is the ability to use profiles. So with profiles, right, and the configuration that you apply, you can go ahead and group it together. So Swapnil discussed about some of our tiering standards. We have a tier 1 and tier 2, right? So if you have something like that where you have either different tiering standards or large offices versus small offices, or even offices that process sensitive data, You can go ahead and group those all together in certain profiles. So that way, when you need to bring a new site online, you can easily connect it into that profile. It can inherit the proper configuration. And so this really kind of can allow you to streamline your deployment and maintain your standards and consistency across the site. Another thing with the VeloCloud Orchestrator is we put a lot of effort into making it the central point for not only configuration, but also troubleshooting. So any kind of diagnostics that you need to perform and any kind of troubleshooting aspect can be done as well from the orchestrator. So you can do things like show your route table or flush your ARP, or look at your neighbor statuses with your different routing protocols. So that can all be done from the orchestrator as well. The second component we have of the topology is the gateway. So we see this at position 2. And so the gateways really serve 2 purposes. They're also a multi-tenant SaaS offering, and they're globally distributed through all major data centers. And so the 2 functions that they provide, the first one is kind of the management plane. So all the VeloCloud edges build overlay tunnels to the gateways. And this is what helps redistribute routes throughout the enterprise to provide that branch-to-branch communication. The other main component of the gateways is to provide an optimal path to SaaS-based services. So with a lot of times these gateways, they're in the exact same code loads as your favorite SaaS services, and a lot of times just a fiber patch away. So we can send traffic into the VeloCloud gateway network and streamline our traffic. And with that option of sending traffic into the gateway network, we also can take advantage of the DMPO, the dynamic multipath optimization. And so this is what's going to help aggregate the bandwidth. And we're going to go over a little bit more on DMPO in a few slides as well to dive into that. There's actually one more component, Swapnil, on the other. Yes, thank you. So here we also have the edge of the VeloCloud edge itself. And so this is going to be deployed right by the customer of client. This is going to be a virtual or physical form factor. And it's going to be kind of resemble a router in the traditional sense, if you like to think of it like that. And so it can be placed at many different places in the topology. We're going to showcase you in some later slides how VMware IT places the edge. And so, yeah. So now we can go into the DMPO here. And so awesome. So what we have here is we have our dynamic multipath optimization. And really when DMPO was created, there were very basic requirements that were kind of laid out to ensure and establish its success, right? So one of them was we wanted the ability to use all the links. We didn't want any more wasted resources, any more links just on standby just in case. And so with this, we wanted to be able to intelligently select the links per the application. We wanted things such as sub-second remediation, as well as low performance impact, right? The ability to provide these benefits without taking up too much of the bandwidth that's being available. And so here we have a couple things laid out. So we have our continuous link monitoring. So VeloCloud's consistently and constantly scoring the link for performance based on a QoE, a quality of excellence score. And so this is going to take into account things like the jitter and the packet loss and latency. And it does this by adding a header to the packet to provide these measurements. We also have the ability to do dynamic per packet steering. And so with this, there's actually a couple of different steering methods available. There's available, which is go ahead and use all my available links. We can do preferred, which is if you prefer to use something like a point-to-point, you can go ahead and create traffic policies to prefer to use certain links. And if that link becomes unavailable or unusable, then use other links. There's also the option to do something mandatory. So if you have some sensitive traffic that you want to go over specific links, you can go ahead and state that that traffic should always mandatory go over this link. And if for whatever reason that link became unavailable, right, the traffic would stop. There's also the option of grouping your links together. So you could combine these policies where you want traffic to go only over your public links or your private links and so on. We also have on-demand remediation. And so this is going to protect against the brownout and the performance degradation, right, which goes ahead if you have multiple links. You can easily steer away from ones that are poorly behaving. And then when they are able to resolve their issues, right, we can go ahead and open it back up and traffic can continue to take all the available links. So we have a photo here. At the top, we can see that there's a traffic type voice. So there's actually 3 different traffic types. There's voice, video, and transactional. And the way this is laid out is we have a before measurement, and then we have after the VeloCloud enhancements. So the VeloCloud enhancement is an indication of remediation that is able to perform to the traffic for packet loss, jitter, and latency. So it looks like we have a diagram here with Comcast cable where our latency is good for voice, but our jitter is fair and our packet loss is at 1.56%. So VeloCloud is able to provide certain remediation tactics on some things when it comes to jitter and packet loss, and is able to turn that from a red into a green trending threshold where we're now able to deliver traffic in a healthy state. And so here's just kind of another example of some brownout protection. So we can see here that in this diagram, we have 3 links, and then we have a score of a 10, and a 5. And so when we're looking at the bottom left picture, we can see that our latency is fair for the video traffic, but jitter and packet loss are good. So again, with the VeloCloud enhancements, we're able to turn that latency into a green threshold, right, and continuously deliver traffic in that healthy state. So what we have here is the traffic optimization via business policy. So we just talked about the different dynamic per packet steering models, right, such as available, preferred, and mandatory. And those go hand in hand with the traffic classification, right? So at a base level, we decide to send traffic either directly out to the internet through the VeloCloud edge, or we send it what's known as multipath, which is into the VeloCloud gateway network. So when you send traffic into the VeloCloud gateway network, you can also take advantage of the DMPO. And so VeloCloud is constantly analyzing and categorizing all the traffic. And so some of the categorizations we have here is real-time, transactional, and both. And so there's a couple examples of each of them, such as video conferencing, business applications, and document and backup. And so VeloCloud does have thousands of applications classified, and they're constantly adding to this list. So when we set up business policies in QoS for specific traffic flows, and we can also standardize this across all of our edges, right? So if you have certain voice requirements or video or a certain application that you want to give acceleration to backups, let's just say during maybe some non-peak hours, you can go ahead and standardize this across all the sites using the profiles as well. And you're also leveraging the app ID, so you're no longer having to worry about source and destination IPs and ports. Of course, that's still an option if that's a preferred method. But there's also now the ability to leverage the app ID to be able to streamline this. And then when it comes to the business policies, Swapnil will take some time later in our work from home case to discuss about how we're using them. Great. So here we have 2 different types of topologies. We have a branch office without SD-WAN and then a branch office with SD-WAN. So we have a couple just to go over this diagram itself and what it entails. So we can see that on the left-hand side, we have 3 edge routers, and each of these edge routers are connected to an ISP. So we have the user, the internal user, that when they need to connect to the internal traffic, right, it goes over the MPLS. We also have the active standby internet. So when the user needs to go to the internet, it goes out the primary internet. And then we have a scenario where if the internet 2 fails, then the traffic fails over to the standby internet, right? And it continues to process. And then finally here, we have a scenario where if the MPLS were to fail, we then have the user access traffic get black hole. So as Swapnil mentioned, this is our tier 2 topology at VMware where we had a single MPLS. And on the unfortunate incident where the MPLS would fail, right, traffic would black hole. And so we would have an outage for our user. And so this changed a lot when we implemented SD-WAN. And so here on the right side, we have a topology very similar, but with SD-WAN implemented. And so now when the user wants to reach an internal resource, they're able to do so over any of the available transports, right? Whether it be MPLS, internet. And then again, now that we have a user going to an an external site, we can now use both the internets through the use of DMPO. And then finally, if we have an MPLS outage with the site with SD-WAN, then not to worry, we can continue delivering our traffic to the internal sites over the internet. So I kind of want to just take a moment here and talk about, because this slide is titled, right, how we fast track our MPLS. And so I'd love to just share a quick story about a situation that we encountered which streamlined this decision. And so it was actually one of our sites that we had just deployed VeloCloud at the time when this issue happened. We had just deployed it a few weeks earlier. We actually had our VeloCloud deployed at a backup state. It was the very beginning of our rollout strategy. And we actually had a small fire in our telco where it destroyed one of our ISP's equipment providing the MPLS. And so we were really nervous watching one of our very first sites without MPLS go full time over the internet. And so we were watching the performance very closely. And it was really surprising, or we were surprised to actually see not that the site was able to maintain its same quality and performance, that it was actually doing much better. And this was largely due to the larger internet pipes that we can normally equip at each site. And so with the larger internet pipes, right, we were able to provide the more bandwidth. And we started to realize that it really forced us to look at the decision whether if MPLS was the right for all the sites. And so MPLS has been like a great and gold standard for many years, and it certainly has a use case. But we started to question whether it was necessary for all the sites and what use cases does it really need to be applied for. And so VeloCloud provides all these benefits, right? We talk about things like aggregation and the remediation tactics and kind of the ease of use. And so this really helped us build the confidence when we had one of our sites lose MPLS, and it forced us into using the VeloCloud full time over the internet. And so that really gave us the confidence to start to fast track our MPLS, or fast track, sorry, our decommissioning of the MPLS.
Thank you, Nick. So I just want to add one more thing to what Nick said. Not only it kind of reinforced our decision, but it helped us put the standard in place. So any site where we go live with SD-WAN, specifically tier 2 sites, we have started decommissioning the MPLS and we have made it a standard. We wait for 3 months, and after 3 months, the MPLS is disconnected on the tier 2 sites. So the tier 1 sites, we are planning to do same thing. The tier 2 sites, as we mentioned, we have 2 internet and 2 MPLS. Our plan is to leave just 1 MPLS there just in case for some time and decommission 1 MPLS. So that has provided significant savings for us, and this VeloCloud rollout program is kind of paying for itself with our rollout. Now that we have discussed the first use case, I would like to talk about the second use case. So we are in like an unprecedented situation right now, right? So due to the pandemic, like lots of companies, most of our colleagues, or pretty much all of our colleagues, are working from home. And since there's so many companies and so many colleagues and so many people are working from home, this has resulted into surge in internet demand, because most of the people are connecting over VPN, or a lot of people are still accessing the business critical application which are hosted in the cloud or the internet. Now, we have noticed over the period of last few months several performance issues due to the high latency, packet loss, and the high jitter. And that has led to degraded performance while accessing the business critical applications, such as the Office 365, as well as Zoom, Teams, as well as several or Horizon desktops. So all these business critical applications, we are seeing the performance impact, and that was affecting our colleagues' ability to do their job more effectively. So our goal with the VeloCloud, now that we had our enterprise use case pretty much halfway done, we are looking at, okay, can we use this for work from home use cases? And our goal was very simple: provide the seamless connectivity and provide them experience as if our colleagues are working within the office. So hence we decided to do the SD-WAN work from home pilot. And during next few slides, I'll go over how exactly that pilot is going on and how it is helping us. So there are also 2 use cases here. The first use case is to provide the fast on-ramp to the cloud and provide the improved performance for our colleagues working from home. So what we had noticed is that there are certain set of applications we have to provide the faster connectivity. And as we discussed earlier, VeloCloud already has the VeloCloud gateways placed closer to all the business critical applications. And since they are placed closer, it helps us provide the connectivity by deploying the VeloCloud device at our colleague's home and provide the connectivity through the VeloCloud gateway. And in the next screen, I'll kind of do a deep dive on how we achieved that. We also were able to take the advantage of the DMPO or dynamic multipath optimization, and we tested the two use cases. We noticed that since a lot of colleagues are working from home and we don't know how long this pandemic is going to last, a lot of them have started looking at ordering multiple ISPs for redundancy at home. So by that, having multiple ISPs, we can provide them automatic failover, and we are able to provide them the connectivity. So that's the second use case that we are looking at. So let's quickly do a deep dive. So how exactly we achieved this? The step one is we shipped a small VeloCloud device, a VeloCloud 510 device to our colleague's home. Once the device was connected to the existing cable modem or cable provider, once that is connected, the automatic activation happened by providing connectivity to the VCO or VeloCloud orchestrator. And at this point, we had a business policies created which allowed us to prioritize the business critical applications such as connectivity to Zoom, Office 365, VMware Horizon desktops, Vonage, and so on. So voice and video traffic along with the business critical applications, we are routing them through the VeloCloud gateway. But at the same time, there are non-business critical traffic, like for example, the Netflix, Facebook, YouTube, Xbox Live, and so on. We want to give that a lower priority. So having this device at home not only helped us provide the better performance, but also provide a redundancy in the situation where we had multiple connections at our colleague's home. And if they don't have a multiple connections, and let's say even if they have only one connection, due to the VeloCloud technology that we have, it provides us ability to take advantage of a link remediation. So even if there is a packet loss, VeloCloud anticipates that and start duplicating the packets ahead of time. So the end result is our colleague don't see any performance impact. So I want to show this, how exactly it helped us. So this is kind of our quality of experience score for before and after. So if you can see, the before the score is 5.76 and the after the score is 9.58 for the video, and the voice it was 7.26, and then after it became 9.53. So as you can see, we have seen that this is significant improvement without really changing anything at the colleague's home. All we had to do is deploy the VeloCloud device and provide the faster on-ramp to the cloud and eliminate or reduce the packet loss, jitter, and latency. So this has been going on quite well for us. So I just want to quickly walk through what's really involved in this process. So the way it works is, what we have done is the step one is the provisioning of the edge. So we have automated this. So the edge is provisioned by using the VeloCloud APIs. The second thing is we ship the device with the factory default config. Then the user powers the device up, connects through the internet, and clicks on activation link. And once the activation link, the user clicks on activation link, the device gets activated. And once the device gets activated, the business policies are automatically downloaded on the device. So the entire process, and we have measured this for almost 45 of our colleagues, the entire process does not take more than 10 minutes. So it's quite seamless experience for installing these edges for us. So this was the first use case. The second use case we are looking at is not only provide the fast on-ramp to the cloud, so all the benefits I discussed earlier, but also provide a remote access alternative or a RAP solution, remote access point. So we have our colleagues use the VPN to connect to VMware internal network, but we wanted to have an alternative as a backup in case we have any problems. And that's why we decided to do the pilot for this use case also. So it's very similar. You get the VeloCloud device, deploy at home, but there is a key difference here is we connect the VeloCloud device, it automatically gets connected to our data center hub, and then it gets authenticated with a network access solution within the VMware network. And the rest of the things remain same. The business critical applications you get automatically routed, and the non-business critical applications are not routed over the optimal path. So this has significantly improved the performance for our colleagues working from home. And so far we have about 50 of our colleagues using this, and we plan to expand this in a month or so for quite a few other colleagues in VMware. So we talked about both of the use cases that we have, the enterprise use case and consumer use case for the VeloCloud. And now I want to hand it over back to Nick to talk about day two operations, or how to support the VeloCloud after it is rolled out in production. So Nick, you want to talk about day two operations?
Yeah, thanks, Swapnil. So here we're going to start off with a couple recommendations of when you're looking to deploy VeloCloud for the first time and go through that. So here we have first a planning phase. And so this is really, I consider a rare opportunity to really redesign the WAN from the ground up. And so kind of an exercise that we did when we were kind of going on this journey is we sat down in a room with, we identified the stakeholders, right, brought everyone together, and we had essentially a whiteboard session, a brainstorming session where we started to imagine what would be the ideal future state of the enterprise, right, if we were to bring in SD-WAN. And what I mean is from the ground up, if we were to design it without any restrictions, without any of the technical debt, right, what would that look like? And so we mapped that out and started to actually work towards that goal by breaking it into much smaller milestones. And so some of the things that we started to look at is like, what was going to be the routing strategy, right? So now that we had our ideal future world, how are we going to break it down, right? So because we can't obviously convert every single site simultaneously. So of course, it's going to have to be in phases as we roll out. So here we have a routing strategy where we want to identify what is a VeloCloud branch office going to look like to a non-VeloCloud site, the NBS. How is VeloCloud to VeloCloud branch traffic going to look? And then finally, what is the branch to hub traffic going to look? And so the hubs are normally and traditionally deployed in data centers or very large sites that require very high capacity. And so when we started to look at this, right, VeloCloud has a lot of great supporting information when it comes to accelerating traffic and aggregating bandwidth, but we wanted to prove that, right? And so we wanted to identify what are going to be our performance baseline metrics. So that way, when we put VeloCloud into the topology, that we can go ahead and validate that we are seeing that acceleration, that we are seeing better performance for our users, and able to quantify that with the solution. And so we started with the phase deployment, and then we moved into the evaluation phase. So with the evaluation phase, right, it's really important with any new solution, right, to just test. So we have a couple of components here that we really focused on, and one of them was the orchestrator. So we traditionally had individual managed routers, and so this was a new opportunity for us to go ahead and centralize our configuration, go ahead and test the use of profiles, and test the consistency and the value that it can bring. Also, it was an opportunity for us to leverage APIs, right? So Swapnil talked about a little bit of our work from home use case and how we're delivering those edges and provisioning them through the use of APIs. We also wanted to craft the business policies in a way that made sense for us. So we started to look at which traffic should we send direct straight out to the internet and which traffic we should send multipath. And of that traffic being sent multipath, right, how are we verifying that we're, again, getting that acceleration? And we did that through the use of business policies. So we used to have business policies in QoS on the traditional routers where it would be very IP-based import. It took our WAN engineers several months to set up some of our global configurations. And so now with the benefits of AppID, we've been able to collaborate with the same WAN engineers, and we were able to perform similar functions within the matter of hours. And so with that, we were able to also do link steering, right? Directing traffic as appropriately, whether we wanted to go through the private links, the public links, whether it should go through all the links and so on. And with the next part, we have the operationalization, which is going to be identifying, again, the teams and stakeholders that you want to collaborate. Really would just encourage that whoever needs to be involved is that they get involved on the ground floor. This is, and with any kind of new technology, right, it's really important to kind of get feedback and opinions from different teams. And because sometimes you might not know what you might not know. And so being able to collaborate on a new strategy is really beneficial. And so with that, we of course need to set up training, right? It's important to know that when this is handed off or whoever is going to support it, that escalation matrices are defined, that you're aware of who is responsible for what changes or the deployment and so on. And then also, this goes in line with, of course, the day two support, right? Who can we call in case there's an issue? What kind of alerts and notifications are you expecting? You know, if things are going well or even if things are going wrong, right? So what kind of actions should you be taking when you receive those kind of alerts? And then finally here, we have the production deployment. So there's going to be two types of deployments. There's going to be greenfield, right? So if you have the opportunity to spin up a new office or data center, right? That's a great opportunity, of course, to insert Velo for the first time and be able to see how things work from the ground up. But for many of us, right, we have a lot of brownfield deployments, which is we already have our offices and data centers. And so really when you look at a brownfield, it's important to consider is where VeloCloud can fit into the topology that best benefits you. And so, of course, there's many different ways, and that's what we would just encourage to sit down, map out what that future state is going to look like, and that way you can decide on where the VeloCloud can sit in the topology, what traffic do you want to run over it, right? You're able to do this in many different ways, whether it's a phased approach, whether you turnkey it all in from day one, or whether you just have it as a backup in case the primary component fails, right, as you build the confidence and go through that journey. And so I'm going to go ahead and hand it back to Swapnil here, who's going to kind of share a little bit of our journey and kind of conclude the presentation portion of the webinar.
Okay, thank you, Nick. So as Nick mentioned, I'll quickly go over the VMware IT journey, right? We started this, our journey back in August 2018. And at VMware, we have very well defined process when it comes to evaluating or deploying new technology. It starts with the paper analysis where we document our business application infrastructure and security requirements. And then we create a success criteria for our rollout. And then we review the success criteria and all these use cases with our stakeholders. Followed by that, we start with the proof of concept deployment. So as Nick mentioned, we performed our proof of concept to validate our design and as well as to ensure that we are able to meet all that success criteria. As we continued with the proof of concept, I would love to stand here and say that everything worked at the first attempt, but unfortunately that wasn't the case. We had some challenges and we rectified them throughout our POC phase. So the POC phase took about 2-3 months for us to ensure that everything is working. So it's like the measure twice, cut once. We wanted to take that approach and ensure that we are 100% ready when we went to the production pilot. When we executed our production pilot, we deployed VeloCloud Edge, or rather replaced our existing WAN routers in San Francisco by deploying VeloCloud Edge appliances. And then we deployed a hub in our Santa Clara data center. And upon completion of the production pilot, we were again able to ensure that all our use cases are working, or our success criteria are working. And at that point, we started planning our global rollout. We continued our global rollout throughout 2019, and by 2020, we have completed about deployments in 12 edge sites or remote sites, and we have deployed 6 hubs so far. And our goal is to continue our global rollout throughout this year and complete it. And finally, since June, we started working on, like beginning of the June, we started working on the VeloCloud work from home pilot to improve our colleague experience. And as I mentioned earlier, our goal is to ensure all the success criteria is met for this pilot as well. And once it does, we are going to present our findings to the stakeholders and recommend the next step, which would be a global rollout to ensure that we can help improve the experience for our colleagues working from home. So this is kind of our high level journey or where we stand today. And so I want to thank you for joining for today's webinar and hope you found it useful. At this point, we would like to take some questions. So if you would like to post your questions in Q&A, we will be able to answer them. And while you are posting your questions, quickly want to go over VMware on VMware program. The VMware on VMware program is where we publish how VMware IT is using VMware products. And the goal here is to share our experience with you so that any challenges we faced, you can avoid them. And you will be able to roll out your any VMware applications successfully. We have several resources here. If you want to schedule a briefing, you can send an email to VMware on VMware at vmware.com. We publish the blogs as well as the webinars as the one we are having right now very frequently. So feel free to take a look at these blogs, as well as you can look at the overall VMware and VMware program, and feel free to reach out to us. So at this point, I'm going to take a look at the Q&A and see if there are any questions there. So let's take a look. So there is a question, how did you guys implement MPLS and ISP circuits on both routers? The separate circuits for each router. Did we have separate circuits for each router? Nick, do you want to take this one?
Yeah, sure thing. And I just want to clarify a couple of things here. So I'll go over both. So when we had our traditional, I believe this question is referencing the traditional sense, as well as I'll answer the SD-WAN. So in the traditional sense, yes, we had ISPs to each router. And so we did a combination of PBX, policy-based forwarding, where we would essentially just attach an IP probe SLA and go ahead and fail over the circuit. And then when we go ahead and look at our new solution and what we have in production today is where we connect both the MPLS and the internet to the VeloCloud. And so it's able to dynamically send traffic over each of the links to the destination, right? It does this through different load balancing methods, as well as equalization metrics of the links. So if you have, example, a 10 meg MPLS and a 100 meg internet, then, for example, you would send 1 packet over the MPLS for every 10 you would send on the internet, right?
Cool. Thank you, Nick. Hope that answers your question. Yash, if you do have a follow-up, feel free to post it. And I don't see any other questions in the chat. So I'm going to give you guys a minute to see if you want to, or a couple of minutes to see if you want to ask any questions. Okay, I'm not seeing any questions coming up, but I just want to say again, thank you for joining today's webinar and hope this was useful for you. Feel free to reach out to VMware on VMware program if you would like to have the follow-up discussions or if you want to discuss a specific use case. Again, I want to thank you for your time.